2005 hurricane season, a year that didn't simply break records, it smashed them. 28 officially designated storms, including the most deadly to hit the U.S. in almost 75 years.
On August 29th, Katrina slams into the coasts of Louisiana, Mississippi, and Alabama. It is the most devastating hurricane to ever hit the Gulf states.
Reaching speeds of 175 miles an hour and ravaging 100 miles of coastline.
Then, on top of the wind and driving rain, more water. Katrina's storm surge is so powerful, it breaks through the levees of New Orleans, the only city in the United States built below sea level.
The barriers that had withstood storm after storm for the last 40 years were no match for Katrina. % of the city floods. More than 1,000 are killed. The sheer destructiveness of the hurricane has become the turning point for many scientists. Although they can't say that one particular hurricane is caused by global warming, many scientists are now making the connections between global warming, rising sea temperatures, and the strength of hurricanes. Greg Holland of the National Center for Atmospheric Research is not surprised by Katrina's ferocity. 2005 also set the record for the warmest temperatures in the Gulf of Mexico, where Katrina spun into a monster.
But it's here in the Gulf of Mexico that they really get going and develop their full destructive power.
As energy from the warm ocean is drawn up into the atmosphere, it condenses into clouds. Winds grow stronger and start to spiral. More air and moisture are drawn upward in the vortex. A self-feeding cycle of frightening power is born.
The really destructive winds in a hurricane extend out for 100 miles or more. And it is so powerful that it could run the entire electric grid of the United States for several weeks.
But like the El Nino phenomenon, it's tough for scientists to separate natural hurricane cycles from the effects of global warming. Right now, it's a hot debate among scientists because we're in a 30-year natural cycle of hurricane hyperactivity. Holland believes it's not the frequency of hurricanes that warmer temperatures are affecting, it's the intensity.
We went back and we got all of the tropical cyclone data for the entire globe going back to 1970. And lo and behold, there was this major increase in Category 4 and 5 hurricanes.
Should the water temperature continue to rise in the next century as predicted, Holland believes that we'll see not only more of the intense storms that defined 2005, they will be worse.
And where a hurricane was a Category 5, maybe we have to invent a Category 6, who knows, to account for the increased intensity.
And it's not just the hurricanes. Scientists say that we can expect severe weather to become the norm rather than the exception. As rainfall patterns are disrupted, heavy rain will batter some regions. Intense floods will become more frequent, while in other areas, severe rain will give way to severe drought. In northern China, rural villages and farmlands have endured steadily decreasing rainfall over the last 3 decades. And in the last few years, there has been almost no rain at all. Every year, almost 1,000 square miles of farmland in China turns to desert. Since the 1950s, that rate has doubled.
There have been a lot of people who've left the village already. People want to improve their lot and move upwards. They've moved to a better place with water and much better conditions.
For these Chinese villagers, there may be no option but to abandon their farms to the sand. This is a phenomenon happening not just in China, but in regions such as southern Africa and India. Around the world, weather and climate are changing. But long before the evidence of global warming became too obvious to ignore, the first computer climate models foretold the changes that we are seeing today. And the vision of the future is far more alarming. Despite the significant changes that we've seen in our climate over the last few decades, it wasn't until recently that the majority of scientists believed that global warming might be the cause.
If you talked to me 5 years ago, I would have been kind of a fence sitter on this whole idea of greenhouse gases involved in climate change.
We'd been looking at the natural cycles for some years, and I was convinced they were the dominant force.
And so it's taken us about a decade to really put the numbers together.
Skeptics will say we've been through this in the long course of history before. We've had spikes and drops in temperature. Why is this different?
What's different now is that we now understand quite well what caused these changes of the climate.
Scientists understand those changes in large part because of these massive supercomputers crunching away at billions of climate equations.
Climate models essentially have come out of weather forecasting models. They run for much longer periods. They run for hundreds of years rather than days.
Professor Peter Cox heads one of the most comprehensive climate modeling efforts in the world, the Hadley Center for Climate Research in Exeter, England. These models break down the Earth and its atmosphere into grids, taking into account all the variables that influence climate.
They contain clouds, they contain rainfall patterns, they contain winds, and climate models also have to contain slower components like how the vegetation and the soil respond to change and how the oceans change.
If you have any remaining doubts that human activity is behind rising carbon dioxide levels and rising temperatures, take a look at the results of this Hadley Center model. The red line tracks the actual temperature rise over the last 150 years. The green line, Earth's natural climate cycles. Watch how it begins to deviate from temperature. The yellow line, on the other hand, is the contribution of human activity to CO2 levels. It is almost a mirror image of the temperature rise. But with a climate system so complex, predicting what the climate will do in the future, that's no easy task.
It should simulate weather patterns that occur, not the exact details because they're chaotic, and each time you run the model you get a somewhat different answer.
Dr. James Hansen should know. Back in the 1970s, he spent 7 years converting one of NASA's weather forecasting models into the world's first model to track the impact of carbon dioxide on temperature and what it would mean for future climate. The results were not only surprising, they flew in the face of conventional wisdom at the time.
Scientists were still thinking the world was cooling off. It had
There
more
was talk about a new ice age, in fact.
Yeah. Well, that was based on just the observation that the northern hemisphere was getting cooler. But when you looked at the whole globe, what I found was that the cooling really wasn't very much after 1940. It was only about 1/10 of a degree, and it was already starting back up.
Hansen focused his research on data showing that temperatures would continue to climb. By 1981, his models were predicting that global warming would emerge as the driving force behind rising temperatures by the year 2000. And the models in the following years proved just as accurate.
We pointed out that if we follow the kind of business-as-usual scenario that we'd been on, that we would get melting of all of the Arctic sea ice in the 21st century, which we're now in. And it looks like that's what's happening.
Hansen Hansen has confidence in his projections of the future because he has tested them against what's happened to climate in the past.
When Mount Pinatubo erupted in 1991, Hansen plugged in all the thousands of climate variables that would follow a volcanic eruption. His model not only predicted the temporary drop in the Earth's temperature and subsequent rise, it was accurate within 1/10 of 1 degree.
But given how much scientists don't know about the climate, can the models possibly be accurate about the future?
I'm concerned enough about the parts of the problem I know a lot about. What really worries me are the surprises, the things we haven't yet figured out. There are lots of positive feedbacks in the climate system, and as Earth warms, they may kick in to an unexpected degree.
Feedback loops are some of the wild cards of climate modeling. Independent, self-feeding cycles that can amplify the effects of global warming. One example, melting glaciers. As the ice melts, more ground is exposed. That ground absorbs more of the sun that used to be reflected by the ice. As the ground warms up, the ice melts even faster. A new cycle is born.